So, this is the example of a Colab book in which we are going to do language identification. Okay. Now, I will use a Colab notebook and we will actually go through how we can do language identification given an audio clip, a speech clip. Okay. So, to do that, first step that I need to do is I will actually upload the I do not need to upload, okay, sorry. So, I will use Hugging Face itself to load the data, right, which is what I mentioned. So, let me go through it. So, first is of course, we have to run this step where we are going to install something called transformers, okay, and the data set, and basically we are going to use torch because we are dealing with deep learning ideas. So, I am just basically installing it as a first step. Okay. So, this is a Colab notebook will be shared by you. You can play around with it. So, I am just leading you step by step what I am planning to do in the Colab. So, as a first step, obviously I am going to install some kind of libraries and packages and so on. So, I need transformers. Okay. So, the idea of transformer, I hope you would have learned a lot more in the text part of it, the NLP part of it. Transformers have two parts, the encoder and the decoder. The encoder is usually used for representation learning like BERT, while the decoder, which is autoregressive, is where we get the generative pre-trained transformers, the GPT, and you can build language models on it. Okay. So, here we are talking about speech. Okay. Remember that. Okay. So, now once I have trained, I have loaded this. Okay. Next, I have to go and do the loading of the data that I am interested in. In this case, what am I interested in? I am interested in identifying the language just by given the speech clip. Okay. So, in this particular case, as I said, it is very easy if I deal with Western languages. So, there is a database called Vox Populi, which is a huge data with many languages, but most of it is dominated by the Western languages. So, for example, you can see that Vox Populi has English about 543 hours, then there is German, there is French, there is Spanish, there is Polish. Okay. So, there are many such recordings of speech, okay, Lithuanian and so on. Okay. So, you have basically this data. So, now this is already there in Hugging Face. So, and I think they would have in the previous previous 4 weeks, they would have told you how to extract data or load the data from Hugging Face. So, this is a standard Hugging Face data. So, I am going to basically use this Hugging Face data, and because I am going to use something outside of it, it will ask me whether you want to do yes or no. So, I am going to say yes, please go ahead and do it. Okay. So, this is a data set that is quite big, and it is now actually loaded the data set. Okay. Now, in this data set, the first step that I am doing is I am telling the loading part that I am going to extract or load the data from Vox Populi data set. Okay. So, there are multiple data sets that are there in Hugging Face. We specifically are looking at the Vox Populi data set. Okay. In this data set, I am asking it to load only the English part of it. Okay. And in the English part, remember that any machine learning, we have two parts, the training part, and of course, there is a valid part also that will come, and then the testing part or the inferencing part, and the streaming equals true. Again, they would have dealt with you. I do not want to keep downloading the entire data, that is going to take me too much time. So, to demonstrate for you for this particular exercise, we are going to take a small subset. You can take a larger subset, but then you have to spend a lot more time doing it. Okay. But the accuracy when you get more and more data will obviously improve. So, I have said streaming. Okay. And next, what am I going to do? I am actually asking it to take that English data set. Okay. And in this case, this first I have started loading the English data set. Okay. So, this is the English data set, but I am going to only restrict myself to loading about 200. In this particular example, I will not even load 200. Okay. I will load 50 just to make my job a little more easier. Okay. So, therefore, I will just use 50. Okay. You can even do 500 or 200, whatever you want, and then I will load only the first 50 entries, only 50 audio clips of this I will take, okay, of the English data set. Okay. So it's just loading. As I said, even 50 will take some time. Okay. 200 will take more time, and then if you're taking 500, it's going to take even more time. Okay. So okay, this is loaded. So this is one language. I'm going to do a 3 language classification. I can do 5 languages, I can do all that 15 languages or 10 languages that are there in Vox Populi, but in this particular experiment we are going to do 3 languages. So another language that I would take is probably Spanish. ES is a code for Spanish. Okay. And again I am doing the same Vox Populi data. Again I am taking the train part of the data and I am putting streaming equals true, because while I download the data I am not going to take the entire data, I am only going to take part of it. Okay. Again I will make it 50. Okay. And so now I will get 50 as my task. Okay. And then third language that I choose is Romanian. Okay. So again I will put train and true. So this is Romanian that I will be uploading, right, and again I will make it 50. Okay. So now I have downloaded 50 audio clips of English, 50 audio clips of Spanish, and 50 audio clips of Romanian. So totally they should be 50 plus 50 plus 50, 150, and that's what you're seeing here. So if you look at how many such things are there, it is 150. Okay. Now this subset, the first 50 corresponded to English, the next 50 corresponded to Spanish, and the third 50 corresponded to Romanian. So let me look at the first row of the data. So this is basically in a JSON format where it says this is the audio ID. Remember, this is taken from Facebook Populi, Vox Populi. Language ID 0 corresponds to English. Its audio is given here. It's a WAV file, and the WAV file, as I said, is digitized, right. So you will get a sequence of numbers. This is like a sequence of numbers or an array, like the samples in the waveform that I am measuring, and I will be sampling it at a certain rate. In most of our examples, we will assume there are 16,000 samples per second, what is called 16 kilohertz sampling. This is a standard sampling that is used for speech. Okay. Then raw text. So if I want to build, we will see in due course, we will actually build a speech recognition system, converting speech to text. So if I have to do that, again I need some kind of labeled data. So in this case, this data set can also be used for that. So that means given the audio, I also need to know what was the text, that's a label. So in this particular case, it says if you do not address this problem, the ground is there for populist nationalism, blah blah blah, right. And there is something called normalized text. We will come to it. Basically there will be no punctuation, no uppercase, lowercase. It's also telling that this is female, speaker ID is so much. Gold transcript means it is actually verified by human and it's perfect. Okay. And accent means it's a neutral accent. Okay. In this case, it's a neutral American English. Okay. Similarly, remember we had only how many 50 plus 50 plus 50. So if I want to look at what happened in Spanish, I should go to the first 50 was English, so I should go to the 51st one. So now it should show Spanish, or the language should change, and yes, the language is now 3, and this is coming from the Spanish data, and you can see that again where the data is located. These are the samples after the analog to digital conversion. Sampling rate is there. See, bien esta, lista, no, whatever, perfecta. This is basically the translation, the transcription for the speech. Okay. Or if I make 101 or 102, right, you should get what? You should get Romanian, right. So you can even check that. So it should be, now the language code should change. So language code became 6. 6 is Romanian, right. So all this 0, 1, 2 comes because of this. Okay. So if you look at it, 0 is English, 1 is German, 2 is French, 3 was Spanish. That's why you took the code 3. 4 is Polish, 5 is Italian, 6 is Romanian. That's why you're seeing 6 here. Okay. So now what have we done? We have gone to Hugging Face, downloaded 50 clips of Romanian, English and Spanish, right. Now, I am going to build a classification system, okay. And to build a classification system, I will not give all English first, then Spanish, and then Romanian, then the system will not learn, right. So, I have to shuffle it, and therefore, I will basically first shuffle it. You can do it later also, but it is done here already. So, do not worry about it. Now, each of these audio clips, and now I have to get a representation, right. So, I am going to use this wave to vec neural network model just like BERT to extract some representation for each of the 3 languages. Okay. So, there are 2 steps that I will do. There is a wave to vec processor and a wave to vec model. Okay. And basically what it is going to do is it is going to take this model, take the audio data, pass it through this big neural network model, and it will basically get features, okay, just like heights and weights. Now, I get some feature that identifies English, another set of features that identifies Spanish, another Romanian, and this has been the wave to vec feature extracts features that are relevant, like how height and weight are relevant for the speech identification problem, okay. And I also need to give the because it is labeled data, I am also going to give corresponding to this feature what was the language, whether it was English or Spanish or Romanian, so that I can train the network. So, first I am going to extract the feature. Now, this is going to be a little expensive, it is going to take time because this is a very big model, okay. So, it might take about 5 minutes or 7 minutes to go about doing it, okay. Sorry, okay. The step I just loaded the wave to vec model and all that, okay. So, so nothing more than that in extracted features, okay. Now, I am going to actually pass the audio files through this and get the features, okay. So, it finished the first audio clip, the second audio clip. It is going to be slow, but you will have to bear with me. I have taken 50 to make it easy, but even this will take about 5 minutes, okay. So, 7 audio clips have been done, right. Remember, I have already shuffled it, okay. So, it is now a shuffled mixed up version of these 150, some there is no particular order. Before it was 50 English, then Spanish, then Romanian. Now, all the 150 is jumbled, okay. Okay, while it is doing, it will take about 2 minutes. I will just explain what kind of a classification method we will use, okay. So, now let me just go here, okay. So, I am going to build a classifier that is based using convolutional neural networks, okay. So, what I am going to do is that I have audio clip 1, from which I will extract wave to feature 1, and I will have the label, because now it is already sort of mixed up. So, let us say this is Romanian, then I have audio clip 2, I have wave to vec feature 2. So, this is the clip, this is the feature, this is the label. I am going to be training something, a classifier to do this. This could be again Romanian, then AC3 can be wave to vec feature 3, this could be Spanish, then AC4 could be wave to vec 4, this could be English, then AC5 can again be English, right, and then again AC6 can be wave to vec, sorry, this is 5, wave to vec feature 6, and this is again Spanish, like that. I am going to do all the way up to AC 150, the 150th audio clip, for which I will extract the 150th wave to vec feature, and I will feed the corresponding label, okay. Now, this is my training data. Okay. So, what I am going to do is, given this feature, okay, I am going to take this feature, I will pass it through a convolutional 1D network, then another convolutional network, then another fully connected network. I am, please bear with me, okay. If you have not, you please go through some kind of a deep refresh your background in deep learning, right, or you can even go back to our speech course, okay. So, this has to be trained, okay, and for each of this clip AC clip, or sorry, the wave to vec feature clip, I know the ground truth here, right? I know the ground truth, so I know the class label, okay. I know the class label, and therefore it will, when I am training this network, it will make error, and therefore I will take that error, do some kind of, because this is neural network, I can use this idea of back propagation, okay, and adjust the CNNs and the fully connected layers, which I am going to show there, but you know, if you are not very clear what is happening here, is basically this is the learning step or the training step of the neural network, where I feed forward something, I will get forward pass something, I will get the output, but it will not match always the label output. So, you know, and I will back propagate the error, and I will keep doing back and forth until my network sort of stabilizes and I get a reasonably good you know, trained network, which will give me you know, the outputs reasonably, with a reasonable amount of accuracy, okay. So, this is the basic idea, okay. If you find it very difficult, please just go through you know, any of those things. Let me just check if I have time, okay. It's only done 65, so I still have some time, okay. So, remember, what are we doing? What is this particular step doing? It is taking the audio clip, passing it through this huge neural network, okay, which is wave to vec, to extract some useful features, okay, and that is still not, that is the feature that we are going to use in our training, okay. So, I am extracting this feature right now. This is the step that I am doing, the conversion from audio clip to the features. I am going to do it for all the 150 clips. That is exactly what that Colab notebook is currently doing it, and then I am going to pass this guy now to the next step, which is building a classifier based on you know, couple of neural network layers, followed by a couple of fully connected layers, okay. So, this is essentially what I will be doing, okay, and to do that, basically I have to initialize in a CNN, you know, you have to tell things like what is the kernel size, right, then what is the you know, the stride, and then the padding, okay. So, if you are not familiar with CNNs, please go back and refresh yourself. In this case, it is not an image, it is a one dimensional vector. Therefore, I am actually going to do just a 1D CNN 1D, okay, convolutional neural network 1D only, 1D convolutions I am going to do. And similarly, for the second also, I have to specify the kernel size, the stride and the padding. The fully connected, again, you know, what is the linear, how many number of neurons am I going to use, and you know, am I going to reduce it, increase it, and so on. And then the final layers, the number of nodes in that particular fully connected, and the output will be only 3 class problem, okay, which will be English or Espanol or Romanian, okay. And so, you will get, because we will use softmax, basically we are going to get some kind of a probability vector, and therefore, there will be some loss, I mean some mismatch, right. Ideally, it should have been only one of the label. If it is English, it should have been one with probability 1 English, the other two should be 0. So, we will use the idea of cross entropy loss, and then we will back propagate, okay. So, this is essentially what we are going to do and train this network. So, if I had no training of the network, there are 3 class problem, right. So, in a 3 class problem, if it is randomly initialized and I have no clue, what is the best that I can do? I can predict, okay, it is A, B or C. Randomly I say one of the three class, it is English, Spanish or Romanian. If I say randomly, there is only a 1/3 chance that I will be successful, right. So, 33 is what we call as chance, 33% that I will be correct is called the chance. If you are doing better than 33, that means our classifier is better than at least chance. It should be better than chance at least, right. And you ideally want your accuracy to be 100, that every clip that I give, it correctly identifies the language. That will not happen. So, we hope that you come close to 100 and we will see what our network is doing. Okay. So, the network that we are going to train. Okay. So, let me see how much we have completed. Okay. Okay. So, I think it is completed. Beautiful. So, now I have completed extracting the features. Now, I will take the data, and remember I took all the 50, but I need to set aside something to test my system and also keep some part to keep it as a valid set. So, what I am going to do is I am going to take the entire 150, right, and take 0.2 of them, or that is 20% of the data, to be as my test data and the remaining as my trained data. So, 80% of the data, when I do this train test split, 80% of the 150 will be assigned to train, the remaining 20% of that 150 will be assigned to test. Okay. But even in train, I want to know how well is my network learning, is a valid, or how well is it generalizing. So, I take this train data itself, again I apply the same train test, but now this, first of all, only 80% of the data came. From this 80%, I am going to take 10% towards validating the neural network, okay, the classifier. Okay. So, this will become a valid data and the remaining will continue to be my trained data. Okay. Then I am going to now extract the, remember the wave to vec features came and the corresponding labels came. So, these are the features and label. So, it is a perfectly trained set, training set is perfect. So, but this training set, I have split the 150 into now trained data, test data and valid data. So, for trained data, I have to extract the trained features and the corresponding labels. For the valid data, when I am validating, I have to know the ground truth, right, and see how accurately I am able to get the predictions. So, that is the valid data features and valid data labels. Once I finish completing the neural network training and validating it, when I want to go into the field and test it during inferencing, I will give a test data which is never seen by the train part, and therefore, I need to know the test features and the test labels, right. So, this is just creating the test set, the train set and the valid set. Okay. So, this is done by that. Okay. Now, I am actually going to build a model, a classifier. Okay. Like as I said, I am going to use a CNN to base, I can use any network. Okay. So, this is something that you should play around with. I have taken simply basically a couple of CNN layers. So, obviously, because we are doing everything in Torch, we need to import Torch and we are using an NN framework, neural net framework, and basically I am going to have only 1D convolutions done. So, I am going to take one 1D convolution done, and that will be the first convolution, then another 1D convolution done, and then okay. So, the input is the input dimension of the wave to vec features. It can be 768, 256. I think we have taken the simplest model. So, the input will be 256, the output channels will be 128, the kernel size is 3, the padding is 1 and so on. Okay. Similarly, we are then going to feed to the next output, right. So, this will take the output from 128, pass it to 256, again another convolutional layer, and again some kernel size and padding, and then I am going to do a fully connected that will take the 256 and give it to 128, then the 128 gives to the output can be only one of the 3 classes that you are interested, right, English, Spanish or Romanian. So, it will get to 3. Okay. I can obviously make the same network to identify 5 languages if I give 5 language data or 10 languages or anything that I want, right. And then I build actually the network itself. So, I am going to take the input data, right. So, this is what I am going to do the forward pass, take the data, do the first convolution. After convolution, I have to do some non-linearity. In this case, we are doing the ReLU, and then the we are going to max spool it, right, and then that output is again given to the next 2 layer. This is con 2, but it's still a 1D layer, the second convolutional layer, again a ReLU and then a max spool. Then we are going to do fully connected 1 layer, and that is what is happening here. And finally, the second convolutional layer will fully connected layer will take this 128 to the number of classes, and that basically is like your logits, and then you are going to apply a softmax, right. So, that is what you are going to do. Okay. One thing I want to point out, so he is just doing some simple things. Remember, the first 0th language was English, the 3rd language was Spanish, 6th language was Romanian, because in the order in which the Hugging Face data set was done. So to make our jobs easier, we will just map them back to 0, 1, 2. No? So Romanian, which is mapped to 0, I will call it 6, I will call it a 0. 0 which was English, I will call it as 1, and 3 which was Spanish, I am calling it 2. It is just relabeling it, okay. And therefore, this is some relabeling part, and then we are going to take the unique train labels, test labels, pass the network through there are only 3 classes. I am going to pass the data through the CNN model. I am going to use cross entropy loss. Remember, I told you this is basically one of the 3 classes. So I will get some kind of a probability vector. So y log, pi kind of thing, and basically that will back propagate, and I am using an Adam optimizer, right, and I am going to iterate this for 20 epochs, okay. And what does this do? This is the model train part. Then the 0 gradient is if I am not accumulating it, so actually it can come later. So I take the input to the features, right, I get an output. After forward passing it through the CNN layers and the fully connected layers, then I will compare it with the labels, I will get some loss, then I will back propagate this loss, okay. So I will do this for 20, and at each step I want to see how my valid is performing, right, and so I will compare the valid loss. So this is the most important part which actually does the classification, okay. Okay. So you can see the epochs coming, okay. I should show you this. So remember, we are doing it for 20 epochs. So it's first epoch finish. You should do more training, okay. We have used very little data and very little epochs, but it's basically going to tell you what is happening, okay. So now I have trained the neural network, okay. What is the next step? That I should now evaluate how well my neural network is, and what do? I am going to take some test data, feed it through this neural network, and find out. For this test data, I know the ground truth. So I am actually evaluating this model and seeing how well it is performing. Remember, if I just randomly picked up 1 out of 3, it will be 33% chance. So I should be closer to 100 than 33, right? See, it's giving you now it's 60.83, depends on data. Let us now run it, okay. So now let us run this evaluation step. So it will pass through the test data, okay, will be passed through this network. So this is test data, and basically you are evaluating the model, okay, and this output, the predicted or the correct labels, and you will compare it with the predicted labels of the test, and okay, you are getting 63.3, okay. So this is not a very good score, but you are doing something reasonably okay, okay. Obviously, how can you improve? These are the questions. Now we will actually give you some variations of this to try it. First, you should do this exercise. The way we are planning is, we will give it, let us say on a Monday, this video, you will play around with it, and we will also give you some ideas of how to change things, how to do things, right. So one of the things that obviously you should be changing is 20 epochs enough, right, or is 50 data points enough, right. So these are questions that you should do. So from a deep learning perspective, if you give more data, the network will learn better, right. So it has more data to deal with. So instead of 50, 50, 50, if I had done 200, 200, 200, my performance will improve. And also I should give, I should not overtrain, but I should give sufficient number of epochs. So you have to see how the accuracy, is it saturating, has it run enough number of epochs. All these things are some aspects of any deep learning problem. So these are things that you have to get sort of comfortable with, so that you can build good systems, okay. So I give you simple examples that I can increase the number of data, I can increase the number of epochs, I can even increase the number of languages to deal with, right. These are all within the same framework. We could also give you other tasks, right. Why I use wave to vec to extract features. In speech, there are other types of feature representations that you can learn, something called wave LM, something called Hubert, okay. whereas normally in text processing there are very standard, there is the BERT kind of representation and the GPT, but speech has so much variability, there are many other ways that I can actually extract features. So you can also try, instead of wave to vec, you can try Hubert, you can try WaveLM, all of these are available on Hugging Face, right? Usually which one is giving a better performance, you should see, and even this is a big neural network, right? So you can even ask questions like, let me go here, if you look at this wave to vec processor, right, they are outputting from the last hidden state, okay. So do you want to output it from the last layer? Can I input it from the middle layer? Does it make a difference? These are the kind of questions and these are the kind of experiments you should play around with and build a speech recognizer, a language ID classifier. And what would be more interesting to you being in India is you can take some, instead of English, Spanish and Romanian, probably you can yourself load in this data. The data loading, I have taken it from Hugging Face. You can take some 50 of Hindi sentences, some short clips, okay, people speaking in Hindi, some short clips of people speaking in Tamil, some short clips of people speaking in Telugu, and build a system. Then you can ask your mother or father, brother, sister, cousin, friend to say something, and you can run this and see if it's correctly identifying the language, right? I mean, it will make mistakes, right? As I said, if you give more data and more epochs, you will do a better job, right? And then you will be, you have built a language ID yourself, right, for Indian languages. So that should be your goal, okay. So thank you very much. I would like to stop now.